Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to be working with tolerance, using an absolute value inequality to put some kind of a bound on another variable. I'll show you what I mean. Suppose y equals 4x minus 7, and we want y to be within 0.05 unit of 10. For what values of x will this be true? So we want y to be within 0.05 unit of 10. That means that we have the absolute value of y minus 10 is less than 0.05. Now we know that y is equal to 4x minus 7, so we can replace y with its formula, 4x minus 7. So the absolute value of 4x minus 7 minus 10 is less than 0.05. Combining some like terms, that gives us the absolute value of 4x minus 17 is less than 0.05. Now we have an absolute value less than inequality, so we can trap 4x minus 17 between negative 0.05 and positive 0.05. We can add 17 to all three branches to isolate the variable term in the middle branch, and that gives us 16.95 is less than 4x is less than 17.05. Finish by dividing all three branches by 4. Let's see, 16.95 divided by 4, that gives us 4.2375. That's less than x. And then dividing 17.05 by 4, that's 4.2625. I better check that arithmetic just to make sure. So I'm going to switch over to the graphing calculator, or scientific calculator, where I'd already worked those out. 4.2375 and 4.2625. And that is what I had. So whenever x is between those two values, then we know that y is within 0.05 of 10. So I'll just write that out, between 4.2375 and 4.2625. Now we're going to try one more. This one has some calculus implications that you'll see when you get there, involving what we call a delta-epsilon proof for a limit. Suppose y equals 3x plus 2, similar to the last problem. And this time we want y to be within epsilon units, that's the Greek letter for E, of 14 whenever x is less than some number delta units away from 4. That's the Greek letter for D. For what values of x will this be true? So we're going to start the same way we did the last one. We're going to start with, we want y to be within epsilon of 14. So absolute value, y minus 14 is less than epsilon. Now we can solve this by splitting, before we do that, I need to think about where I want to end up. And I'm trying to show that x is less than delta units away from 4. So I'm trying to get there. I'm trying to show that the absolute value of x minus 4 is less than delta. So that means that the inequality that I wrote first, I need to end up with that looking like absolute value of x minus 4 somehow. So let's take a look at what we can do. We'll replace y by its formula, 3x plus 2. So absolute value of 3x plus 2 minus 14 is less than epsilon. Simplify by combining like terms. Absolute value of 3x minus 12 is less than epsilon. And I can see where that x minus 4 is going to come from, because there's a common factor of 3 in those two terms that I can factor out. The absolute value of 3 times x minus 4 is less than epsilon. And I can split that absolute value into the product of two absolute values. The absolute value of 3 times the absolute value of x minus 4 is less than epsilon. But the absolute value of 3 is 3. So I can divide both sides of this equation by 3, and that's going to isolate the absolute value of x minus 4. So we get absolute value of x minus 4 is less than epsilon over 3. That is my number delta. So here, the solution to this problem is delta equals epsilon over 3. It'll be okay if you forget how to do this by the time you get to calculus, but you're going to see it early and often when you make it to that class. All right, that's it for our 2 problems on tolerance. I'll see you next time.